And I know Carl mentioned briefly about asset management, so we're going to move on to Kiona Leah. Kiona Leah is a professional licensed engineer who graduated from Rensselaer Polytechnic Institute in Troy, New York, with a BS in environmental engineering. She worked in private consulting for over 10 years and then moved on to work as a transportation design engineer for the Maryland Department of Transportation State Highway Administration in 2011. Her design accomplishments include an award for partnering from the Maryland Quality Initiative as part of a team that worked on the largest drainage retrofit project the division has funded to date. In 2015, she was promoted to the Stormwater Systems Assets Manager. Her accomplishments and vision are recognized at national levels with a grant for the State Transportation Innovation Council to spearhead development of a document management system that will integrate across platforms to best inform operations and maintenance work on the stormwater facilities she tracks. So, Kiona?
Thank you, Susan. I'm Kiona Leah, like she said, and I could talk about this topic for about 5 hours, so I brought my phone with me to time me because I only have 20 minutes, so please bear with me. And this is kind of the start of our presentation here, and you can sort of see my information there. Our agenda. First off, I'm going to start off by talking about our program size and scope, asset management at a glance here in Maryland, our data management and some of our challenges that we've gone through, inventory and condition inspections, visualization of our analysis, which has been really key in making this program a success, risk and criticality, and formalizing asset management planning, and of course questions at the end. So just a real quick on the size and scope of our program. Our program was started over 20 years ago. It's quite a legacy program that I got to inherit 7 years ago. And we originated, based on the information in the 70s when everything became law, and was in 1999. You can see some of the statistics on the screen about our size. One of the main things that I did with our program when I had to start talking about it was I divided it into the 3 distinct categories, which is why I call it stormwater systems. We have our drainage networks, we have our stormwater management facilities, that's what I like to call them, and our dams. And you can see the numbers up here on the screen of how many of each of those we had. We did a full inventory, and I think that was completed in about 2009, so we had kind of a count. When I inherited the program, there were approximately 3,200 facilities. Today, there are over 8,400. So I also had to deal with an explosion in size. And we have just a few dams that are currently recognized by our DEP as large in size, but that may be changing soon. One of the things about asset management is you really have to understand how it works as a systematic approach. And there are lots of diagrams for this. We used to have a much more simple diagram that just had our planning, our engineering, construction, and then monitoring and operations. But as we start formalizing asset management, what we really look at is how do we start with a strategy? And that is our data management. Some of the DOTs that are out there, we're lucky enough to be able to go, hey, we have to build this from the ground up. We have nothing. We have no data. We have no risk assessment. We have planning. We have things that we have to count. That's all we know. And they get to do all of this at once. We sort of started, since it was 20 some odd years ago, piece by piece. And we really started with that data management piece. How do we set up counting all of these things and mapping them and knowing where they are? Then we do inventory and inspections. We move into design or analysis, depending on whether you're at the beginning of a project or you're in the middle of the life cycle, you might need to do one of these 2 things. Of course, we build it once we design it, if you're moving through that. And then a big piece, and the one that's close to my heart, is operation and maintenance. How do we make sure it's still working? How do we train our engineers to remember this is not just lines on a plan. This is not just the regular set it's okay. This is a living, breathing, growing, changing thing that has to work for the next 30, 50, 75, 100 years. And a lot of times I find with our young engineers, that is the hardest lesson that they need to learn. So I like to drag them out in the field and see those BMPs and facilities that have failed and those pipes that have collapsed so that they remember these are real things. How do we rehabilitate those things as they come to the end of their life? Or how do we know that they need to be replaced? Do we create really in-depth plans? Do we create napkin sketches? Do we do a full retrofit? And sadly, when is it time to just let them go and dispose of them? So our data management, like I said, challenges in data management. We had to build a system and a schema. We were lucky enough that our DEP, to some degree, gave us information about where to start and what information they wanted to see. These are complicated systems. They get updated regularly, and one thing that I always emphasize every time I speak to any group about anything asset management related is talk to the professionals. How many people in here have a degree in data management and GIS? Yeah, none of us. We're all engineers, or probably all engineers or planners. We are not experts at building a database. Don't pretend you are. Hire the people who are. They revamped my program in such an amazing way when I came in, because I was absolutely lucky enough to have someone who knew what she was doing and was not shy about telling me what was wrong. And it made all the difference in understanding and relating, this is the information I need. I need to know what is a facility, where is it? I need to know what status it is. Is it existing? Is it proposed? Is it under retrofit? You don't have to put all of that in one space. You can put it in different boxes. So that's how you sort of see these boxes and how they're related to each other and how they spread out into other tables. So just like our Excel spreadsheets that we like to do that have multiple tabs, your database will have this too. This is a very, very small portion of my entire database. So if you look at the very top over here, there are 3 arrows coming into that big table. That's because there are 3 additional sets of tables that feed just that. So these databases get complicated really quickly when you have to track everything, and especially if you have to track thousands, which eventually you will. Even if you only have a couple hundred now, it'll keep growing. We all know this. Oop, too many slides. So we also have to develop processes. Inventory and condition and inspections is a process. It has 3 main distinct pieces to it. It has working in your office, and it does not matter what type of inventory or condition. It doesn't matter whether you're inspecting your pipes and your ditches or your stormwater facilities or your dams. They all have to kind of go through this same process. You start in the office. Often this is your GIS intense work, especially nowadays. This is where your professionals can come in very well, or lucky enough like I am to have someone who is sort of a unicorn and can learn these things and do both. But you have to work on your database. You have to version it, because unless you're sending only one inspection team out there, there's going to be a lot of people out there all at the same time, and you don't want them putting all their data right into the same database. You have work groups. You want to track that. For our stormwater facilities, we actually have a tracker. How many people would like to know what's going on in the field right now while you're sitting at your desk? I know I do. So my data professionals built me a dashboard where we pretty much real time at the end of every day, my inspectors hit submit, and I can see all the dots, all the places they went. And I can watch the map go from yellow, all these need to be done, to green. Really, really, really helpful. Connections, joining your databases, joining what information out of all those tables you need out in the field so that the tools are set up. And often with our people who go out and deal with emergencies, how many emergencies are they seeing in a day? 1, 2, 3. When we go out to inspect, we want to hit as many as 20 to 30, and with our drones, we've done as many as 70 sites in a day. You got to plan for that, and you do not want to be sitting on the side of the road doing that. Do it in the office. Very important, making those orders in those groups. Once you actually get out in the field, we have field tools that we update, again, so I can see that in the office, and we track those. We use different tools. Our big ones are we like to use customized off-the-shelf solutions from mostly Esri products. Arc Collector and ArcGIS or Arc Field Maps and Survey 123 are very, very, very popular. We brought those in after many, many, many years of having a custom designed system that, as I inherited the program, I got all the calls from all the consultants. We don't run Arc Engine 9 anymore. We don't even have it. We can't get it upgraded. What do? We really don't use Tough Books anymore. What do? So having those systems that are nimble and working with OIT people to make sure that as technology improves and enhances, you can stay on top of that because your consultants are going to, right? Again, a lot of us work for government agencies and we know it's like turning the Titanic to get us to change and do things. So work with those type of solutions. And then when all that is done, it comes back into the office. It gets quality controlled. We verify the logic. We actually have a whole process. Again, our OIT people do a lot of work behind the scenes to make sure from those, some days, 20 or more tablets are out there collecting information, make sure all that information comes back in, the data is clean, the logic that they've used, the information and the parameters that they inspected actually got hit and collected, or they were marked as NA. The photos and the watermarks were done really well. And all of that is stored and ready. If you're looking at inspecting pipes, how are we inspecting pipes? Probably video. We're probably running a rover or a drone through that and inspecting. How do we store all that? Because that's a lot of data. Inventory and condition. So here I'm going to talk a little bit about the pipes, which I just mentioned. Right now, most of what we use is CCTV or video pipe inspecting, and you want to be able to have that phasing as well. You want to initiate that again in the office. How do we find out that we need to do this? In Maryland, we have over 9 million linear feet of piping. That's a lot of pipe to just go out and start inspecting if you haven't started. So we have to prioritize when we get calls about emergencies, when we have projects we know we're going to do, or if we have maintenance that we're trying to schedule or repaving, we're trying to inspect those pipes in that way, in that manner to prioritize. How do we do pre-field? Can you run a rover through a pipe that's full of sediment? No. Make sure it's clean. We have to coordinate our MOT. We're still sitting on the side of the road. We may have to vacuum and clean inlets to get there. And how do we access them? Then we actually get to do those. We get to do the inspections. We want to train people. We need to load that data. Again, this is even more data because it's video driven than what we have for stormwater facilities. And then we review it and manage that. Inventory of outfalls. We have a separate program for outfalls that's robust like our stormwater facilities, and we use similar tools of ARC Collector and ARC Survey 123, and we're using tablet technology. We do our outfalls in kind of two pieces in a way. We've got our outfall, the actual pipe and culvert, and then we have the structure itself, and then we have energy dissipation, your riprap, but not your downstream. So you can see in this graphic what's inspected and what's not inspected of these outfalls. The downstream condition is a whole different separate category. For our stormwater management facilities, here's a picture of our dashboard that was just from this year. You can see it's the end of the year because everything is yellow and there's nothing to inspect. We also have our tracker that I talked about. A lot of times with our stormwater facilities, we can't get in there to inspect it. So the one graphic that has all the different colors on it is if my inspectors can't get there and I need to call maintenance to go, I need you to clear me a path to the facility. I need the fence taken down. I need the poison ivy and poison oak gotten out of the way. We have a way of knowing that and seeing that as well. They also will inspect on 33 total parameters, so there's a lot. When we do our more simple facilities, we will collapse that information and then only inspect the things we need to for our swales, but they're all available if needed. We do photos and we can photo locate things, which is really becoming useful within our database, especially when we start using our drones. And then we have lots of additional tools to track that, like I talked about previously. Inventory and condition. Here is actually some of the stuff that we're using on our drones themselves. So drone organization takes even more GIS and data-driven work if you're going to do it. But that's how you get super efficient in the field. Before you go out there and take your flights, you want to make sure that you collect and plan. They can actually create all the points they're going to take photos from the drone on the desktop before they do it. You want to determine the angles you need to take it at. They work much better at an angle, by the way. Flying straight over a facility gives you a very flat picture. Flying at an angle gives you much, much better resolution. We learned that on our first day in the field. Automated flights work better, but they're not always possible. You, of course, also need a pilot for your drone. We may like to play with them in our backyard, but when you go out into your right-of-way, they better have a license from the FAA to fly that drone and know all the laws, because there are a bunch of them. I did not know that. We were able, with only 2 teams in 3 field days, to inspect over 220 grass swales. Even on our best day walking, we would have gotten 120 with that many teams in that many days. So 100 additional facilities were inspected right away. Post-flight, again, your GIS professionals and your data professionals are going to take all that data from the drone, and they're going to map those photos, and they're going to give you the information so that you can look at them more in detail to actually determine things. The resolution on these things, by the way, are absolutely amazing. And some of the other things we're looking at, I have a picture here of one of our drones that's in a cage. If you want to send it through a pipe, make sure it's in a cage, because if it falls into the water, I've also heard of some of our consultants have them with pontoons so that they'll float if you send them over a pond. Haven't seen one of those. We just took the risk and flew ours over the pond. My cover photo was actually from our drone. There are a lot of data information, but the efficiency and the safety to your inspectors, we really believe can't be beat, and we're working now to create SOPs so that our inspections next year can use this. Inventory, condition, and assessment. Once we gather all this data, we need to assess it. We need to decide, are things in good, fair, or poor at minimum condition. You can see on the screen, we actually tend to go for 5 condition assessments. And anything that we rate at a 3.8 or higher are considered in good state of repair, so that can either be excellent or good. Anything from a 3 to a 3.799, that's a typo, are in fair condition. Those are probably things that we're going to work on rehabilitating. And anything that's below a 2.99 is in marginal or poor. We may need to retrofit it, or we may need to have a funeral for it. This is what our drainage network looks like. This is just the map, but again, we visualized our data of looking at and what we could do for now, because we don't have inspection and condition information for all our pipes, was we looked at their age and their material and where on their useful life spectrum are there. We also looked at what don't we know either of these 2 things for. So as you can kind of get out to the western part of Maryland, you see there's a lot of gray. We don't actually know how old or what they're made of out there much of the time. We just know that they're there. Where do we think we need to start figuring this out? Out there. Obviously, if we've got our reds or our pinks, those are at or past useful life, we may want to start replacing those regardless. This is kind of the summary of those colors that you just saw on the map. And we do have a lot of missing information. This is how we're prioritizing what we're going to inspect, what we're going to start researching first. This is what our stormwater facility system looks like. We've got much more robust data. We have some of the most robust data in our DOT in this part of my program. But we always have to reevaluate, we have to reinspect, we have to look at it every year, and then again, for the color coding, we re-look at it. Once we get those inspections back, we actually look at it a second time. We have an engineer go through and decide what action does this need. No action, which means as scheduled, send maintenance out there. Routine maintenance, oh, it's starting to get a little off. We need to send them now to just collect the trash, dig out the ditch or whatever. Does it need rehabilitation? Is it in that fair category, or is it going to be more of a major design? And we plan that, and our asset management office helps us work on prioritizing that and creating an asset management plan that formalized a lot of that. Risk and criticality. So we've seen some different risk matrices over the past week, and this is mine. This is where we look at the impact that failure is going to have and the likelihood is going to fail. The likelihood is kind of what I've been talking about up to this point. It's the inspection, it's the condition. How likely is it that it's going to fail? Obviously, what we've been talking about more is looking into the future. I'm looking both at the past, what is it actually now, and how quickly is that going to fail, but what impact is that going to have? A lot of our impacts, obviously, regulatory is one of the first ones we look at. Are we going to get a consent decree? Are we going to get something that's going to stop construction? Very important. Of course, we're a DOT, so public safety is way up there on the list, and we weight all of these. Do we have funding and support to be able to fix this, and how do we best use the resources we've got? As well as that resiliency piece and the security of the organization itself. So when we look at this, this is actually what we did for our drainage networks. You can see a little bit more of the information here on the risk factors that I talked about for our pipes. How critical is it? How safe and close to the roadway is it? These are some of the criteria that they looked at. What are the connections and emergency routes? We heard people talk about redundancy and redundant routes as well. What are the impact to some of our other assets? Is it also causing failure of an outfall? Is it also going to potentially make a dam a risk? That's obviously a very big one. Private property and damage. Urgency based on the people in the field. We rely heavily on our districts to tell us, yeah, this is a bigger problem, because we're not boots on the ground all over the state. They are. Political push, of course, we all have to deal with the politicians. If it's Senator such and so's backyard, and remember, we're in Maryland, so we've got senators that live right where we are. If they're calling our governor and saying, we've got a problem, obviously that's going to get fixed, even if it's number 1042 on my list of important things. And future degradation. So we start to use and compile all this data to make those data-driven decisions so that when I have to go, sorry, Mr. Senator, you're 1042 on my list, they can start to understand why and what logic we've created behind that. For our stormwater facilities, because our data is so robust, we actually created an automated matrix for this. And this slide actually gives you all of those pieces. One of the things that we're currently in the process of doing is categorizing all of our stormwater facilities for dam safety. That's part of a request from our DEP. Because we don't actually have that categorization right now, is it a high, significant, low, just a straight up pond or no dam at all? We're using some of the inspection parameters to give us that information at this time. But again, we're looking at our regulatory information and other parameters. We rank them 1 through 5, and we actually mathematically have a formula. And you can see some of the weighting at the top. I know the text on this slide is kind of small, but the likelihood is obviously very important because that's one part of that. And then under the criticality, we look at consequences and we look at other parameters as well. And we get a mathematical formula. Once we get a number, it's pretty easy in an Excel spreadsheet to rank all 8,000 facilities to show us which ones we want to start prioritizing. It's a great and very useful list, but not until you figure out where things are. So the next piece of that is formalizing that and actually grouping those facilities and starting to map them, which is what you're seeing here, is you can actually see where we took the facilities and started mapping them and going, okay, where can we do a rehabilitation project where they're just gonna go out, they're gonna dredge it, they're gonna replant grasses, they're gonna cut down trees, they're gonna move on. Or where do we need to completely rebuild? Where do we need a new riser? Where do we need computations to actually create that? And how much can we afford? Which is always one of the first things. My boss just goes, this is how many dollars I need you to figure out spending. Okay, so this is kind of how we did that. And we look at all of those different things, we rank them, and then we say, this is what we think we can do in fiscal year 23 and 24. So far, we only have 2 years worth. But considering all of those ratings, and this is actually an initiative that they're working on for our entire DOT for all the different asset classes. Because we have such great data, we were able to do it in ours and work again with some of our IT people to look at putting it back into our database so it'll be available in the database and mapped. We kind of had to go through a very iterative process to get it there. But this helps us go, here's why we picked what we picked. As we apply this to our drainage network, as we obviously have our dam information as well, it's going to be easier and easier to create interesting, good, large-scale projects that really we show have an impact on what we're doing to create all that resiliency that we have. And then the last little piece is the actual asset management plan that we're creating. A lot of times as H&H people, I think we become unaware of some of the other things that happen in our DOTs, but every DOT has to do a transportation asset management plan that they submit to Federal Highway every 2 years. And it's a formal document. Guess what it's on? Pavement and bridges. Now, the bridge people are probably happy about that, but for those of us that really just work with these smaller facilities, I've been waiting and waiting and waiting. And we're actually being put in as an appendix to our TAMP that's going to Federal Highway as information, and it's to further our conversation. Our asset management office has supported me tremendously in putting this document together, and we've used subject matter experts to create that. And it has all of the pieces that I just talked about and that life cycle that you saw at the very beginning about asset management planning, as well as things I didn't talk about here, our financial planning and forecasting, the gap in how much money would we need to really bring the entirety of our system to performance, which is a big number, and how are we going to invest the small amount that we do have in that. So that is my presentation. I did go a little over, and I apologize. Are there any questions? Yeah.
Are you uploading the drone footage to the database, or how are you managing those files?
We are. So what we've done so far in our pilot study is we actually have just photographs. We don't have video yet. So the pipe, we've got a little bit of pipe footage, but not a lot. But the photographs, yeah, we are uploading them to the database, and OIT already looked at that and said, oh, we need to give you more space, because those photos, like I said, they're 5K cameras on the drone. So for those that are kind of familiar with high def, 4K, this is even further. So they are very crisp, they're big files. So they did act to give us more server space. And for our program and our division, we're lucky enough to have our own dedicated server. So that's how we're managing that. We are still looking at how we're doing it with the video footage. We've seen some systems where they have a cloud that an offsite is managing that. So we're still looking into that for the video footage. Yeah.
How do you ensure consistency amongst the raters? You have all these inspectors that are going out, 20 different teams.
Training. We have very robust standard operating procedures. So we start there, and then usually about every 2 years, I retrain everybody. In 2020, we actually couldn't hire consultants to do training, so we had to do it all in-house. I had to pull all of it in, and we had to learn the entirety of the system from soup to nuts, including that GIS part I talked about. I recorded all of that, and we actually have recorded trainings that are available. So this year I just went, I'm not paying for training, here are your videos. But that's one of the ways that we do that. And we also have a visual guide that we created a number of years ago that is available in the tool. So they can pull up while they're in the tool, here's what good, fair, poor retrofit looks like on these different facility types. So that was a big part of where I started in the program about 5 years ago in particular, because the people who were rating in the office told me exactly what you just said. We're not getting consistent information. We need more consistent. I'm like, oh, people need to be trained, and we need more visual tools for them to understand what they're looking at. So that's the best way that I've found to do that. Yeah,
You're
you.
collecting a lot of data. Can you talk a little bit about the lessons learned from the database, on the database side, different groups, how do you work together to get that data talk?
One of the biggest things is to really leave that to the professionals in OIT and talk to them all the time. All the time. Anytime we have to do anything. And also working with them to have the people who work in the day-to-day trained was another really huge piece of it. When, the woman who kind of, in a lot of ways I like to say trained me on how to work with the data, pointed out that she had a master's in data and GIS. So she was really an expert. So we had her train us on what pieces we could be in. The other big piece is to do versions of your database, which I kind of touched on, is no one except the professionals work in the actual live database. Everyone else gets a version. So every week or on a regular basis, and again, it's a procedure that's not particularly complicated, but you want your GIS folks to teach you how to do it. They will teach you how to create a duplicate copy of the database. That's what we work in. So even my engineer day to day, he works in a duplicate of the database. Once that duplicate is done on Friday, Monday morning, the actual data professional syncs that. And when they sync those back together, they will get errors that point out this conflicts, this information is suddenly missing, this information is not working properly. So that's another way that we really manage all that. We do the same thing with all our inspection teams. They each get their own version, and those versions get rolled up and checked on a regular basis. So that's a big piece of how we do that as well. Great question.
Yeah, one more question.
Yeah.
Do you have shared use facilities too?
Yes.
Where you can, how do you manage that with them? I mean, do you all end up doing the inspection for them? Or do you just carry it down to a certain structure?
It depends on, again, it depends on, I know, someone said, like, make sure that you really memorialize your agreements, right? That's what you said? Same thing. It really depends on what the MOU says. And we are working on tracking and making sure we have all that available. Again, clickable a lot of times through a web map that we can see it. We're still working on gathering all of that and automating it a little bit more. But it really depends on, are we responsible, are they responsible? But we do track all of those. That's, again, part of that tabling. So I've got the facility. One of the tables that relates to the facility is ownership. Do we fully own it? Is it joint owned? And again, we track all the ones that just treat our water. So it may be privately owned, but it's still in my database because we need to account for the water, not just the facilities, but I don't need to inspect that facility at all. So that related table of ownership in particular is how that works.
Does somebody else then take it from there?
Yes.
Like position?
Yeah.
So you guys go out and realize your system's bad, you need to upgrade. Are they gonna do their effort to the downstream or,
Yeah, and it's having those conversations and finding those MOUs. My favorite one was the one from 1960 that I had to deal with Amtrak, where we were still responsible for that facility right next to their tracks, and it was quite a ways off of US Route 50. So yeah, that's why you got to memorialize them. Like you said, you have to know what you're responsible for and what they're responsible for and how to work with everyone and who has what piece, because sometimes they have part of it and sometimes we have part of it. We are always happy when someone calls and says, I know it's yours, but it's really ugly and it's in front of my Wawa store. Can I cut your trees down? We're like, don't tell the DEP. But yes, please. We're more than happy to have people help us. We've actually been working on what we like to call an adopt a pond program, where people want to come out and pick up trash and potentially mow around the facilities. So we've been working on that, just like your adopt a highway. I have an adorable sign for it too. It has ducks. We're all about the ducks in our division. Thank you, everyone.